Ad Astra is our mantra. Ad Astra to the stars. Ad Astra, it's who we are.
Welcome to Around Space. I'm Kent Miller. Today we're going to be talking about Planet 9. There's a claim just recently published that there may be another large planet outside the known part of our solar system. I'm delighted to have with us Dr. Bradford Baer, astronomer and optical engineer. In 1992, he got his bachelor's in astronomy from Williams College in Massachusetts. In 2000, he got his PhD in astrophysics from Caltech. From then until 2003, he worked at the McDonnell Observatory in Texas, and from then until 2007 at the Naval Observatory here in Washington, D.C. After that, he branched out into the private sector, bringing spectroscopy down to Earth. Welcome back to this table.
Thank you, Kent. It's great to be here, as always.
Planet 9.
Maybe. All the press releases and newspaper headlines say Planet 9 discovered, but it's not a discovery. We haven't seen it. There's circumstantial evidence, and to their credit, the two researchers who are making this claim, the title of their paper is Evidence for a Giant Planet in the Outer Solar System.
Okay.
So this is the potential start of the hunt for Planet 9, but certainly not a discovery by any stretch of the imagination.
Right. Now, this gentleman, the lead author, as I understand it, is the very same guy who claims to have killed Pluto.
Yes, Dr.
Right.
Mike Brown from Caltech. He's an observer, and he and his collaborators, he certainly doesn't work alone, they've discovered a lot of the large bodies, the dwarf planets, out beyond the orbit of Neptune, and as well as a lot of smaller so-called Kuiper Belt objects. The Kuiper Belt being this fuzzy disk of small icy objects that orbit out there. The discovery of several objects that were as big, maybe even bigger than Pluto, was one of the nails in the coffin that led to Pluto being demoted from true planet to dwarf planet by the International Astronomical Union.
So Pluto's really now one of quite a number, actually. Yeah.
Right, the biggest, or the first discovered of these KBOs, Kuiper Belt objects. The recent flyby of the New Horizons probe has shown that it's a world, even if it's not officially a planet. It's a very interesting place. It's got a whole bevy of moons. And so the debate, I'm sure, will rage on as to where you draw the dividing line for a planet. But this supposed new quasi-discovery isn't, if in fact this Planet 9 is out there and is as big as Brown and his collaborator, who's a theorist, they estimate that it's at least 10 times more massive than the Earth. So either it's a planet or Earth isn't, and I don't think anyone's willing to demote Earth to a dwarf planet status.
Now, my understanding is that this proposed Planet 9 is really something that's inferred by looking at the orbits of other Kuiper Belt objects that we have already seen.
Yes, exactly. Brown and all his collaborators have been finding more and more of these objects, enough that you can start doing demographics on them, looking at the different families, both in terms of what they look like, but even more importantly, what their orbits look like, how they are moving around in the outer solar system. They're not all following nearly perfect circles like most of the inner planets. They are, in many cases, going up out of the plane of the ecliptic, the flat plane of the solar system, or down very elliptical orbits. And what Brown and his team found were a set of about a dozen of these Kuiper Belt objects that looked very similar. They were all orbiting, not right next to each other, but following a very similar set of orbits. And in particular, 6 of them have almost exactly the same perihelion, that is the distance, the point where they're closest to the sun.
And the aphelion is all more or less on the same side of the solar system.
All of these long, skinny ellipses are
Yeah.
pointing in roughly the same direction,
Right.
which could happen by random chance, but you wouldn't expect them to stay aligned in this fashion.
Well, it might be an accident of just the way we observe.
The so-called selection effect, and that's
Yeah.
something that astronomers always have to be careful about. Are you seeing a representative sample, or are you only seeing the objects that are easy to see? You know,
Right.
So you'd be biased towards objects that are going to be closer in and therefore easier to see, or brighter, or something of the sort. Now, the authors on this paper are well aware of selection effects. They use standard techniques to compensate for that, and they estimate that this sort of alignment of orbits could happen by random chance, but a lot less than the chance of that happening is much lower than 1%.
Okay.
So it's suggestive, certainly not conclusive.
Right. Now, there's this concept of shepherding. We see this in the rings of Saturn, where relatively small moons seem to be able to shepherd large numbers of those little particles that make these beautiful rings.
Right.
So tell us a little bit about shepherding.
Well, so these Kuiper Belt objects that they've seen, or this particular subset of them, that all seem to be aligned, they would tend to wander off into their own separate orbits over billions of years, over the history of the solar system, unless something was keeping them in line. And so what the researchers did was run a number of computer simulations of some much larger unseen object, Planet 9, which tugs at just the right time, is on some sort of semi-synchronized orbit with these Kuiper Belt objects, and gives them a little nudge to keep them lined up in this fashion. And they tried a number of different configurations, the giant planet being in a much larger, somewhat circular orbit that would kind of keep them contained, and that didn't really work out. A whole lot of different permutations. They somewhat accidentally stumbled across a rather counterintuitive setup where the giant planet, actually, the ellipse points out in the other direction, but it's synchronized. So every, I don't know how many hundreds of years, it comes back, and as it's passing through the neighborhood, jostles the orbits of those smaller bodies so that they stay lined up and stay pinned to this particular location
So
in
there's a
the solar
shepherding
system.
effect.
So it's a sheep. The big planet is a sheepdog keeping the sheep in line.
All right. Now, how really plausible is this? We now have, thanks to the satellite called Kepler, we now have seen hundreds of solar systems. Do we see solar systems with more than 4 gas giants?
We're starting to discover them. The first exoplanet discoveries, planets orbiting around stars other than our sun, were just 1 or 2 really close-in giant planets. But as the technology has advanced and as we've had more time, we're finding solar systems, sometimes very young solar systems, with 3, 4, even 5 large Jupiter and Saturn or Neptune and Uranus-sized planets. So it's certainly not out of the realm of possibility. I mean, our solar system is certainly special because we live here, but there's no reason to think that it's all that different from most of the other solar systems out there. So if 3, 4, 5, or even 6 giant planets are possible in other solar systems, it's possible here as well.
Okay, so there's a plausibility.
Right.
1 more gas giant is
Yeah,
possible.
there's no rule
Right.
that says you can only have 4.
Okay, yeah. All right, now, you mentioned something that I guess we would call dynamical modeling, and that's where you use a computer and let the orbits go for, 1 billion years or something and see what happens.
Right. It's really the closest astronomers get to doing experiments. It's a simulation. It's not the real thing, but you can first of all, you don't have to wait billions of years to get your final answer. It happens much more quickly, and you can twiddle the knobs and try different things and then see, as is the case in a lot of physics and astronomy and other branches of science, you create the model and then try to get to match what you actually see. And that was one of the other things that struck me about this pre-discovery, or this hypothesis, is that it doesn't just explain those 6 Kuiper Belt objects in that one orbit. They, in their simulations, they found there was another set of Kuiper Belt objects which were sort of sent off in a completely different direction by the gravitational influence of.
These are the ones that tend to fall through the almost perpendicular to the ecliptic.
Right, they are sticking out perpendicular, orthogonal to to where most of the other planets are orbiting. And when this other population showed up in the simulations, Mike Brown realized, oh, wait a second, we've been finding some of those as well. And no one really had any good idea of how they got way out there.
Right.
So not just that one, but I think there were 2 other populations of KBOs that are explained, sort of retroactively predicted by this model, which is additional evidence, circumstantial, and it's not a slam dunk, but it definitely is enough to get people to sit up and take notice of, hey, that maybe they're onto something here.
All right. I guess my understanding is that this is actually a very large orbit. It's like 200 astronomical units, 1 AU being the orbital radius of the Earth, right? So 200. So this is well beyond Neptune,
yes.
right?
I mean, even at its closest.
It's 200, and the furthest is 600?
Something like that. I don't remember the exact number.
That's a huge orbit.
Huge orbit, very slow. I mean, this thing is going to be, take much longer than even Neptune or Pluto to complete one cycle around the sun.
So it's well beyond Neptune or Pluto. So that raises the question of how easy is it going to be to find this thing?
Well, that depends where on its orbit it is. And they have a prediction, at least, of the shape of this orbit, where the close point, the perihelion, is, where the aphelion is, and, as I said before, how massive this body must be in order to be able to do its shepherding job. There's no way of telling where it is along this orbit. It's not like the somewhat similar example from the history of astronomy, where Neptune was predicted, not just its existence, but where it was in the sky, based on aberrations, slight discrepancies in where Uranus was. In that case, you had one large object pulling on another large object, and with some very clever math back in the 18th century, they made predictions of where Neptune was. They looked there with a telescope, and only 1 degree away found Neptune. In this case, these Kuiper Belt objects it's a sort of average over a long period of time. The shepherding, we're not seeing the direct tug of Planet 9 on one of these little KBOs. It's the cumulative effect over many, many orbits. So where Planet 9 is on this orbit, if it even exists, even if it's on that orbit, we don't know where it would be. It's enough, it's narrowed down enough so that some very targeted searches could be done with the large telescopes.
So there's some arc in the sky where they...
Right, it's going to be somewhere along here, and chances are I mean, given that it moves faster when it's closer and slower when it's further away, chances are that it's further away. But the large telescopes around the world with very sensitive detectors should be able to see it. If it's that massive, it's going to be a certain size, and even if it's a very dark object, it's still, you can calculate how bright it should be, and therefore how long you have to stare to be able to see it.
Well, let's talk telescopes. Many of our best and most sensitive telescopes have a very small angle of view, the field of view. So it could take years to search little by little through this.
They're probably not going to send Hubble out to look for this. because Hubble is like a super telephoto zoom. You want a fisheye lens, or at least the astronomical equivalent.
Right.
And there are a number of telescopes specifically designed to do that. In fact, that's been an important part of astronomy since the 1930s and 1940s, building so-called Schmidt telescopes, which are configured to be able to see a large field of view with
It's a wide-angle telescope.
wide-angle lens. And the equivalent sort of wide field telescopes do exist today and have already been surveying the whole sky. So it's possible that Planet 9 has been seen, but it hasn't been recognized as a moving object. It just looked like another star.
Right. Now, my understanding is the Japanese have a telescope called Subaru.
Right.
It's in Hawaii.
It's in Hawaii. It's one of the larger ones. It's more like a telephoto, but like a lot of the other large telescopes, it's got a CCD, a computer light sensor chip that's enormous. It's actually a mosaic of many others. So Subaru might go on the hunt. The Chinese have a project called LAMOST, LAMOST, and I forget what the acronym is for, but it's a segmented telescope that has an even wider field of view. The Sloan Digital Sky Survey in New Mexico has been scanning the sky for lots of different projects. They might borrow that for a little bit and do some specific targeted searches along that arc you talked of, where Planet 9 is likely to exist.
Now certainly, a scientist with a computer and a digital database is going to be much less expensive than getting one of these big telescopes online.
Right.
So you would anticipate that they would first look at already existing images.
If those images were, as astronomers say, deep enough, if they can see faint enough objects, that there would be a chance of seeing this large object, and particularly in the infrared, even if this object is very dark, it might still be glowing with its own residual heat from formation, and so it would show up in, for instance, the WISE survey, which was a small space telescope in the infrared that scanned the whole sky and then managed to get half of the sky before it ran out of coolant.
Oh dear.
So searching that, I'm sure they are already hard at work pouring through those files and those images to see if it can show up. In addition, other theorists are certainly going to come up with their own simulations and see if they can reproduce the results of these two researchers
find alternative explanations for
this clustering, exactly.
For what we see.
So 6 months from now, they may retract it, or at least say, oh, wait a sec, we didn't realize this, this, and this, and there's nothing special about this clustering. On the flip side, the evidence might get even more compelling. So this is the very early stages of the discovery, or not, of Planet 9.
Right, so we would expect that the first steps would be a search of existing images.
Yes, and perhaps if they do have, Mike Brown has access to some of the very specialized telescopes out at Palomar Observatory, which he's used, in addition to many others around the world, that he's used for looking for these Kuiper Belt objects. So it might make sense to go hunting with live data to back up or to get a alternative measurement to the archival data, looking at stuff that's already been collected.
Okay, so I was just wondering if, because his argument is really, I don't want to say house of cards, but it's inferences.
It is.
And is the argument strong enough to justify booking time on one of the big telescopes?
Right.
Yeah.
Well, that's up to the committees that are in charge of allocating that time, and Brown and his collaborator can certainly make a good case that it's worth putting a little bit of time in on it.
Yeah.
But this is how science works. You come up with a hypothesis, you bounce it off of a few trusted collaborators, and if it passes the giggle test, then you say, okay, let's share it with the rest of the community. We'll publish a paper, fully aware that it might not be right, but you put it out there, and people try to poke holes in your argument or try to help you verify it. So it's, and in one of the press releases, Brown specifically said, I'd love to discover this, but I'd be tickled pink if someone else discovered it as well based on our calculations. That the important thing is get other people to put their brain power to work and either find it or refute it, prove that no, it's not out there.
Right. A little risky, so he might not get his name on this one.
Yeah.
Let me ask you a different thing. We have some models for solar system formation, for the early years of creating a solar system. But this hypothesis suggests we have a large heavy object that's far more distant than the gas giants that we already see.
Right.
So that leads to the question: how did this object get created in the first place? If it did start within the normal confines of our solar system, how did it get perturbed and wander out to this great distance where, can you comment on any of that?
No, that's a very good
It's
point.
the origins question.
And again, exactly,
Yeah.
not just how it formed, but where it formed.
Yeah.
And in this paper, the authors do talk about that briefly, although it's not their area of expertise or focus. But the two most likely explanations or origins, one, as you sort of alluded there, is that it formed in the inner solar system, just like Jupiter, Saturn, Uranus, and Neptune. In fact, a lot of people think that all those 4 planets formed much closer, not a whole lot closer, but somewhat closer in, and gradually migrated out as the disk of debris that came out of the solar nebula. As that disk gradually either was dissipated or absorbed into these planets. And there's a lot of, sort of like a game of billiards, that with planetesimals, the cores or the building blocks of the planets all flying around, crashing into each other. We have a pretty good idea that our moon was formed when something the size of Mars crashed into the Earth and caused a huge plume of
Debris.
molted debris that then coalesced into the moon. So the early solar system was a very dynamic place, and if this fifth gas giant core had passed too close to Jupiter, it might have gotten a gravitational slingshot that flung it out into the far outer solar system, and then had some other perturbation to keep it in that distant orbit.
As opposed to escaping the solar system.
As opposed to escaping the solar system altogether, which, if it's that far out, it was not too far away from actually escaping altogether.
Yeah.
The other possible explanation, is that disk of material was much larger than the solar system we know today, and that Planet 9 formed out there and has stayed out there. So we don't have a whole lot of evidence one way or the other right now, but as time goes by, if we discover this thing and can measure what it's made of, then that will provide some important clues as to whether it formed out there or formed closer in and migrated.
I would somehow suspect that forming out there, the distances are enormous out there, and everything's moving slowly out there too. So how would it collect as many Earth masses as they think?
Well, the paper references a potential gas giant core. It is much bigger than Earth, if their calculations are correct, but not anywhere near as big as Jupiter.
Right.
So it may have been, the solid material that was similar in size to Jupiter and Saturn and Uranus and Neptune at the beginning. It traveled out there, and exactly as you say, it didn't have much of an opportunity to vacuum up additional material, whereas
Jupiter did and became much heavier.
Exactly, pulled in. There was enough of a rocky or liquid core. The gravity was strong enough to pull in gas and create Jupiter is mostly gas, a very thick atmosphere with a solid or metallic hydrogen center. So the Planet 9 might be that middle part without all of the gas and pretty bands and great red spot and such.
Yeah.
And if so, that would be incredible, an opportunity to essentially see deep inside Jupiter and Saturn.
Yes. So because the current belief is that all these gas giants have a solid core.
Right.
And then maybe there's just one more out there without the gas.
Exactly.
That'd be brilliant.
You get to peek behind the curtain, as it were, and see what, making certain assumptions that it is representative of its cousins of the inner solar system.
Amazing. All righty.
So it's just the very beginning of this story. It might turn into something big, or it might fizzle away, but
So in a few
it's
months
exciting.
we'll know whether it's a dud or whether the hunt is on.
yes, exactly.
The hunt is on. All right. Well, thank you very much.
My pleasure, Ken.
All right. That was Dr. Bradford Baer. He's an astronomer and optical engineer talking about Planet 9. Thanks for joining us, and see you next time.